Fermat's little theorem states that if f has a local maximum or minimum at x equals c on its domain and f prime of c is defined, then f prime of c must be 0. To justify any theorem at all, we assume the hypothesis. In this case, the hypotheses are f has a local max or a local mean, and f prime of c is defined. We then need to show the conclusion. The conclusion in this case is f prime of c equals 0. Keep this in mind. We will assume or suppose that the function f has a local maximum at x equals c, where c is an interior point in the domain. By the definition of the local maximum of the function f of x as x equals c, where f of c is the highest point, it must be true that f of x is less than or equal to f of c for all of the x near c. What this means is that near c, f of x minus f of c is less than or equal to 0. So if we assume that f has a local maximum, then we automatically have f of x minus f of c being a non-positive number, negative or 0. And that is part of the hypothesis. Another part of the hypothesis is that f prime of c is defined. If f prime of c is defined, then f prime of c exists. But also, by the definition, f prime of c is the limit as x go to c of f of x minus f of c over x minus c. Since f prime exists, this limit exists. And since this limit exists, the limit at x go to c on the left-hand side of f of x minus f of c over x minus c needs to be the same at the limit at x go to c on the right-hand side of f of x minus f of c over x minus c. As of now, we are approaching c from the left-hand side and to c from the right-hand side. F of x minus f of c is always less than or equal to 0, and so the numerator is less than or equal to 0. The denominator x minus c at x go to c from the left-hand side, x minus c is negative, and so on the left-hand side of this equal sign, the denominator x minus c is also negative. If we have a negative over a negative, then the quantity on the left-hand side has to be positive. On the right-hand side of the equal sign, f of x minus f of c is always less than or equal to 0 because f of c is the maximum value. On the right-hand side, at x go to c on the right-hand side, x minus c is positive. And so in this case, the denominator is a positive number. A non-positive over a positive number is a non-positive, or simply put, a negative number. And so on the right-hand side, this is a negative number. And remember, the two limits have to be the same. If the left number is positive and the right number is negative and they are equals, the only possibility for that to happen is that both have to be 0. And so this shows that the left limit is 0 and the right limit is 0. Therefore, f prime of c equals 0 because the limit exists. The limit is f prime of c.